Welcome to Lean IT Foundations. Today we will be covering Section 2, Systems and Tools, the PDCA, and DMAIC methodologies, Part 2. We did complete Part 1 in an earlier session. Please review that before moving on to Part 2. Section 2A, Part 2, Process Improvement Systems and Tools, PDCA, and DMAIC methodology. Today we'll be diving more into the DMAIC methodology. In Part 1, we covered the Define, Measure, and Analyze section. Today we will be covering the Improve and Control section of DMAIC. I am your speaker, Anthony McCollum, and I am a Process Improvement Specialist. Let's dive into the Improve phase. There's 5 key things that I want everyone to take note of when we dive into the Improve phase. First, generate creative solution ideas. Step 2, cook those raw ideas. 3, select a solution. 4, run pilot testing. And 5, actually implement your project on a full scale. Step 1, generate creative solutions. In this phase, what we'll actually do is some brainstorming. For brainstorming, I like to recommend an affinity diagram. So we've gone through the DMAIC process so far. We've defined our problem, measured it, analyzed our issues. We've come up with what we think are some of the root causes, and now it's time to brainstorm some ideas for solving those problems. One effective tool is an affinity diagram. We'll cover an affinity diagram on the next page in more detail. We also want to set a quota for a number of ideas if we do have a group of people when we're collecting our affinity diagram ideas. So an affinity diagram, what we're going to do here is actually literally pass out a bunch of Post-its to everyone and say, hey, everybody, I want you to give me 10 ideas. That's setting a quota for ways that we can improve this particular process. Everyone will write their ideas down on a Post-it, and we'll collect all of those Post-its, right? So this is us building our affinity diagram. Again, if you're doing this remotely or digitally, what you can do is have everyone send you an email with 10 ideas. Again, this is a way of gathering up. If you have 10 people and everyone gives you 10 ideas, you now have 100 ideas to implement creative solutions to solve your problems. So you want to brainstorm today and check on those ideas on another day, right? So today, the day that you're generating ideas, that's it. All you want are ideas. You don't want to necessarily check the validity of those ideas. We just want to get ideas on the board. That's what we're doing in the first step of this brainstorming session. And it's important to think outside the box. If you're the project manager or you're the improvement specialist actually running this project and folks hit a wall, it's okay to act a little quirky. It's okay to say crazy, outlandish ideas that may seemingly never work. Because what those crazy ideas do, when you're saying crazy things outside of the box, is it spurs other thought process. So let's take a look at an affinity diagram. So I mentioned literally passing Post-its out around the room. Give everyone in the room 10 Post-its. Tell everyone you want an idea on every single Post-it about a way to solve the root cause problems that we identified in the analyze phase. What you do is you'll stack all these Post-its up on a board, and then you'll start reading through each one of them. And what you'll do is you'll actually start grouping those ideas together. This is creating the affinity diagram. So again, you're going to have a lot of different people. Everyone's writing down a lot of ideas independently, but the fact is a lot of those ideas are going to be related. So group those into related ideas. Then you can create subgroups within each of those groups of ideas. Those can actually be identical ideas or identical projects that people, or ideas that people want to do to improve this actual step. Stack those right on top of each other. Where do you start? The group and the item that has the most matching identical ideas. That's where you start your project. That's the improvement that you start working on to implement. I mean, you can do multiples if you want, but you're going to have a lot of duplicates as you start to see these and move over. So it's important just to have a good starting place. That's how you build an affinity diagram. Next thing you're going to want to do is called cooking the raw ideas, right? So you combine those affinity ideas and you link them to the root cause issues. So you want to make sure that all of the ideas that you're going to do to improve or implement your solutions are related to a particular root cause or issue. Document the idea in full, right? So whosever idea it was, if it was multiple people that had the exact same idea, let's talk about it. Let's write down ideas. How can we expound on this idea? And identify where it lands on the practicality scale. What is a practicality scale? Well, let's take a little look here. Again, you got a lot of ideas, and what you do is you throw them up on the board. Again, just take those ideas from a particular group and stack them up on the board. There's 5 levels on the practicality scale. The middle being possible. To the left, we have seems like an impractical idea. To the far left, it seems like a pretty way out there idea. We go to the right, they become more workable. To the optimal ideas, the one that we really want to take on immediately, are the ideas that we can implement today. So as you start to work out your practicality scale, you'll move those Post-its around and see exactly where they fall into. And hopefully we'll end up with something similar to this, right, where we'll have 2 ideas that we can actually go out and really get started on today. Then we're actually going to select the solution. So start with the obvious solutions, right? Those things that fell on the far right of our practicality scale, or things that just seem like no-brainers, things that we don't have to reach across company boundaries or get approvals for, or get other executives to sign off on our participation. Those are the things that we want to dive into. The minimum requirement for picking an idea is, does it directly attack a root cause that you identified in the analysis phase? It's okay if you want to write up a formal analysis, just depending on the type of environment that you're in or the time that you have. And you want to make sure that we understand the impact and effort assessment. There's a matrix that we'll take a look at on the next slide to understand that in more detail. So this is the impact or effort metrics, right? So the amount of impact that an improvement idea is that we want to implement versus the amount of effort that it will take to actually implement that. There's 4 quadrants that everything falls in, right? If it's a high impact idea that requires minimal effort, that falls into category 4, the quick wins. Those are the key ones that we really want to dive into and go for. If it's going to be a high impact, take a lot of work, it might fall into the major projects category. Those will take more time. If it's a low impact, doesn't really require a lot of efforts, those are just the fill-in things that we can do along the way as we have some extra time. I mean, they're gonna impact our problem. They'll eventually help. We don't necessarily want to spend a lot of time on those, but we'll work on those when we can. And then the thankless tasks, the things that take a lot of time but don't really have a lot of high impact. I mean, those are the things we'll get to last within the project. And, we may take those Post-its and then stack them around here on the board. Again, we really want to wind up in the quick wins or start tackling major projects. Again, those things that are going to require a lot of efforts, we can get started on those today, but let's not plan on spending the majority of our time on those. We want to focus on those quick wins. Next step, step 4, pilot testing. Pilot testing is absolutely critical when we are working to actually implement our improvement ideas. We want to make sure that those improvement ideas are going to work, right? So it's great to pull out a pilot, see if we can test our ideas on a small scale. You can also plan your entire project out, or at least the test phase out, on a Gantt chart. We have an example of a Gantt chart on the right here. Again, this is just a way of listing out everything that needs to be done, identifying things that rely on each other, right? If we can't complete step C until step B is done, then we can see that on the Gantt chart. We're even able to put in the number of resources and the amount of time that it'll take for us to get that done on the Gantt chart. Great tool for when we are working out the pilot testing to help us work out the kinks and understanding how long it's going to take to actually implement on a full scale. When we're piloting, we want to define the start and end date of a particular pilot. Pilots are not designed to last forever. Make sure that the scope of the pilot test area is clearly defined, right? We don't want to go outside of our boundaries, involve people that shouldn't be involved. We want the people that are working on a pilot to know who they are, know the reason that they're doing it, and the impact that they can have if we do wind up going forward with this on a full scale. So that will help them to understand the importance of doing the tests the way it's designed to do. And that brings us to the actual implementation on a full scale. So with this, there can be a lot of training involved, documentation, troubleshooting, making sure that the people that will actually be doing this know and understand, what we're looking for here as far as performance goes. We want to make sure that when we are planning on implementing on full scale, that if our new idea that we are going to implement can literally affect their bottom line, right? How much money they make. We may have people that are working on a piece rate. We may have people that may lose overtime, for example. We need to make sure that they understand that how this can affect them and ensure that their performance with this new process and the way that they're managed won't be adversely affected, right? Or otherwise we lose the buy-in of the people that are on the floor doing the actual work. And again, if you don't have the people support, the project will fail, right? If the people are against it, it won't work. So when you are implementing on a full scale, your plan to get those folks to buy into what you are doing, to support what you are doing, has to include some sort of a performance-based measurement. It may include a new pay scale, depending on the type of improvement that you're implementing, but we have to ensure that we are including those people's futures in the implementation on a full scale. And that includes a way to measure what we are doing. Some other things that we can do in the improve phase is actually create our future state map. What is it that we actually want this to look like once we're done? And actually try new things if we're not exactly sure of the idea that we want to do. So we may have a few ideas, we pick one, and let's just try it out. And if it doesn't work, what we do is called go back to measure, analyze, and repeat. The DMAIC cycle is a cycle. You're supposed to continually go around that circle. You start with defining your problem, measuring it, analyzing it, testing improvements. If they don't work the way you wanted them to work, go back to define, measure, and analyze, and figure out why they didn't work. Try different improvements. It's okay to keep going in a circle if you're not getting the results you want, but it's important to make sure that you go back to measure so that you understand why you're not getting the results that you were looking for. Moving on to the control phase, there's 4 key areas that we will cover. Discipline, documenting the process, ongoing process measurement, and process management plan. So the control phase, maintaining a process whose operation is stable, predictable, and meets customer requirements. Most important concept there, meeting customer requirements. So this is the last step in the DMAIC process. We've defined a problem that we're encountering. We measured that problem. We've analyzed what we see to be the root causes, and we've implemented improvements. The whole concept of this control phase is to make sure that all the work we've done on this project, all the improvements we've implemented, all the time we've spent isn't lost and reverts back to the old way that it was before we even started the project. So the control phase, the first step, discipline. An old adage, old habits die hard. Once you get to that implementation on a full scale, important to note, people don't like to change. Even if it's a new process, people might make more money doing it this way. It might be easier. They'll work shorter hours, make the same pay. Doesn't matter. People don't like change. One of the hardest tasks that you will have as a lean leader is being humble to the concept that even though you are trying to help someone, to help a process out, to help our customers out, that those folks may not be as open to it as you think that they should be. So it's important to try to install some level of discipline within the thought process, right? So there's a couple ways. Discipline may seem like a harsh word, but there's really two levels of discipline that we'll discuss here, and some approaches within that. There's the organizational level. Evaluate and reward employees on the process. So this gets back to what I was talking about when I said if we're going to change the way people do their jobs every single day, we also need to change the way that we evaluate and reward the job that those employees are doing. That has to be a part of your improvement plan. If you implement that, that will help control to make sure that the system stays the way you want it to be. If you have folks that are measured on number of calls versus call length in the current state, but you're trying to improve quality, so you want people to spend more time, but you don't change the pay scale to reflect quality of the call versus the number of calls, and people will continue to pump out phone calls. You have to change the way you evaluate the employees with the way that you are changing the process. This is a way of controlling your process improvement. Another great way of doing this on an organizational level is to identify a process owner who is going to continually monitor the new improvement to ensure that it doesn't revert back to the way it was. Who's going to do that? You also have to give this person tools. You got to give them the KPIs. You got to give them the ability to monitor it. You have to give them the authority to monitor it. Now, it doesn't necessarily mean they're the ones that have to go around with the stick. It can simply be someone who manages a dashboard and notifies folks if they're falling out of the boundaries, the control limits. Discipline's a harsh word. We'd never ever use that word if we were actually implementing this or talking about this with people, but these are some of the tools and the ways that you can go about installing discipline in the control phase. Those were the organizational techniques. Let's talk about the personal technique. Two key things to get people to buy in and control or sustain an improvement project that you've been working on. The biggest tool at your disposal is to get people to understand why. Not the, hey, everybody, we're doing this, kumbaya, it's going to be great, but truly understand why we're changing the process. If it's because customers are unhappy, make sure that the people doing the job know that. Let them read customer reviews. If they're making a physical product, give the people that are making the product and say, use it. You tell me what you think about it. Would you be happy with this as a customer? Make sure that the people that are doing the job, doing the process that you want to change, understand why you are working on a project to change the thing that they do every day. Because old habits die hard. People don't like to change. Especially if they possibly have to work a little bit harder or work a little bit longer. And kind of in line with that is lean training. As I've stated throughout this entire series of presentations, lean does not work unless everyone within the organization is involved. The entire concept behind the Shingo model and the way that lean is meant to be implemented in today's business is that you get the frontline employees involved. Everyone whose job is going to be affected by this new process change that you are working on needs to know what waste is, what value is, what variability is. The core basics that we are covering over the course of these sessions, you should cover with these folks as well. Get them involved. We all need to start thinking in a lean mindset. It will make your job as a lean leader, as an improvement specialist, a lot easier. Let's talk about some documentation now. Again, these are all ways that we are going to control the improvement that we have implemented and sustain it to make sure that it does not revert back to the way that it was. So you're going to create some documentation, whether it's new process maps or SOPs, whatever it is. Here's some things to keep in mind when you're creating your documentation. Do keep it simple. Do not include a lot of jargon, especially a lot of technical jargon. Folks that are working in the job today may know a lot of the technical terms, but someone who gets hired tomorrow won't. And if they weren't here during the old process, they may not know the new process technical terms. Keep it simple. Include pictures and videos and flowcharts. A, B, C, D. This is it. This is the step. Include graphs, if you can, running graphs at the actual station where the work is being completed so that people can see how they're doing. It's a great document, an actual running chart to see how people are doing. And involve the people who are doing the process. When you are creating documentation that will manage the way people do their job, make sure that the people who do the job is involved in writing their own documentation. This is good because A, number one, nobody knows it better than them. B, if they help writing it, they're going to feel a much greater sense of ownership over it. And see, they're also going to understand it a lot better. Some other things to keep in mind when you're creating documentation. Be sure to anticipate problems. So if you can, within your documentation, include what ifs this happens. And this is another great reason to pilot test, as your pilot test may highlight some issues that could possibly occur when you're working on a particular project. Take note of that. When you're doing your pilot testing, you should be writing everything down, documenting everything that's happening. And checklists are also a great tool. They're easy to understand, especially if we're talking about closing out a particular area. You have to follow steps A through D before you end your shift or something like that. Checklists are just a great documentation tool to include. Ongoing process management. We want to make sure that our SIPOC diagram is completely updated. We want to measure process outcomes from the customer perspective. In Lean, everything we do is about adding value to our customers. So once you've implemented your improvement, go back and double check and make sure that what you've done is actually adding value in your customer's eyes, that it wasn't just a superficial improvement within the organization. And monitor upstream links as well, ones that are critical to your process. Keep in mind, when you're looking at your SIPOC diagram that you created throughout the DMAIC process, a lot of the things that you're improving is specific to that middle step, the process and the SIPOC. What happens if your suppliers change something? What happens if the quality of your inputs changes in the future? How will that affect all of the process improvements that you've made? Keep those things in mind when you're looking at controlling all of the work that you've done on implementing your new project. More on ongoing process management. Again, nothing's going to be better than charting your data, making sure that you are monitoring the outcomes of your process. Create nice, simple, easy to read dashboards, and make sure that everyone can see those, right? It's important to think about when you're creating these tools, how are you going to get feedback from your customers? How are you going to compare your customer's reaction before and after? I mean, is it customer surveys? Maybe your customer works close to you. You know, there's different types of customers and there's different ways of getting feedback. Incorporate your Pareto charts and your histograms and use control charts. Let's talk about control charts. The next few slides are going to be based on control charts. What is a control chart? Well, you will essentially have a new set of data, right? So you've implemented an improvement within your process, and now it's time to see if your improvement worked. Well, how do we do that? Well, if you remember back in the Lean versus Six Sigma presentation, we reviewed this bell chart. And we noted that the way a bell chart works is taking note of that concept of what Six Sigma is. So when we're taking a look at a bell curve, remember this guy from high school, you have an average, and that average is surrounded by standard deviations. One standard deviation on both sides, two standard deviations on the other sides, right? 68% of your data falls within one standard deviation from your average. 95% of your data falls within two standard deviations of your average, right? So again, if we go back to that example about your drive to work, if on average it takes you 45 minutes to drive to work with a standard deviation of 5 minutes, what you are effectively saying is that 68% of the time you leave your house, you will arrive to work between 40 and 50 minutes. If on average it takes you 45 minutes to drive to work with a standard deviation of 5 minutes, you will arrive to work 95% of the time between 35 and 55 minutes. Okay, again, average is that most typical number that comes up in your set of data, and the standard deviation is the same thing as a sigma, right? And this is why we are looking at Six Sigma and how Six Sigma is very closely incorporated with Lean when we're implementing process improvement. So what a control chart is it simply turns this bell curve on its side. And it plots it out horizontally instead of vertically. We actually can even eliminate the actual bell curve itself. On the y-axis, we'll have our drive time to work. On the x-axis, we will generally have some sort of a time management based on the details of the process that you are working to control. This control chart will help you keep track of that over a certain period of time. Your control chart can run hourly. It may be a daily control chart or a weekly control chart. Again, it just depends on how much data you have and how closely of an eye you want to keep on your data. What will eventually happen is you're going to have data that starts moving around within this control chart. And what you do is you set for yourself what's called an upper control limit and a lower control limit. As long as your data falls within your control limits, you don't have to do anything. The process is working the way it is designed to work, within your control limits. You can set your control limits wherever you want. Again, you can set them within one standard deviation or two standard deviations. Remember, again, within one standard deviation, your data should land 68% of the time. Within two standard deviations, your data will fall 95% of the time. So you may set a limit for yourself, and you may say that, hey, if I'm 5% out of my range, either on the high side or the low side, that's when I want to get worried. It's actually 2.5% on the high side or low side. But we're not going to worry about the details. Point is, you set a control limit for yourself. You can say, hey, it took me more than 55 minutes to drive to work today. What went wrong? Was there an issue? Was the freeway closed? Did I have to wait for my carpool buddy for an extended period of time? Is that an occurrence that I'm worried about if it'll happen again? What you do is if you go outside of your control limit, you zoom in on that occurrence and you ask yourself, what happened? Why did this happen? And you do a little mini process improvement project. Ask yourself, why did it happen? Ask yourself, why 5 times. Here's some other things that might happen with your control chart data. Is you might see a trend in a direction. It can be up or down. These are what we call warning signs when we're taking a look at our control charts. If you have more than 6 or 7 data points trending in one particular direction, there's something going on with your data. Go back to where your data started to trend down and ask yourself, what's going on with my data? Why am I trending down or why am I trending up? You know, down or up can be good. It just depends on your process. If it's sales, it's bad. If it's turnaround time, it's probably good. But when you see the trends in your data on your control charts, it's just a flag to say, hey, oh my gosh, I need to go and see what's going on. Another thing that might happen in your control chart is it's hovering around your average and never goes outside of your control limits or any of your sigmas that you've identified for yourself. Remember, it should only be within your control limits 68% of the time. So out of 100 occurrences, if all 100 of them fall within that 68%, what you need to do is tighten your upper and lower control limits. Set new expectations for yourself. You may also have to shift your entire control chart in an up or downward direction. Again, if the majority of your data is no longer hovering around your average, then you have to take a look at your data and make sure that you set the correct control limits for yourself. So let's take some control chart notes. Again, the whole point of this is to show variability within your process, but within certain guidelines. And also note that it's not necessarily about what your customer wants when you set a control chart. A control chart is about guidelines that you set for yourself that are internal to your process. For example, if your control is to deliver a pizza within 30 minutes, you can gauge yourself to find out how often or not you are hitting your 30-minute mark, and you manage yourself on that. If you're going over consistently, you identify what's causing that delay and you fix it. So moving on from control charts, let's talk about the process management plan. What we have here is just a very simplified example of what's called a process management chart. What a process management chart is, what you'll literally do is draw out your process map on an actual piece of paper or a diagram of some sort, your management chart, and identify the critical steps within your process. If, for whatever reason, an issue occurs, draw out a plan. What happens if? Set your action alarms. So what is the if? When do we act on our action plan? What happens if there's emergency fixes that need to take place? What do we do? How do we handle these particular things? If you're going to make sure that your problem does not revert back to the old ways, people tend to go back to the old way of doing something if something really bad happens. They go, oh my gosh, that didn't work because. We have to anticipate these things, and we need to come up with a plan so that the people doing the job every day know what to do when it happens. In this example, we have the process map listed out in the left column. You have an incoming call, you're going to process a request, and then you're going to close out a request. a very simplified process map. But, again, process maps live in all levels. In the middle column, we have how we are monitoring each of these critical steps within our process map. For incoming calls, we might have live counting or a ticker. What do we do if our calls peak, for example? Let's say we only have enough people working the phones to handle 100 calls an hour. And we're monitoring those calls, and we see that we peak up to 140 calls. What do we do? What is our response plan if we go outside of our danger zone? The response plan may be to have some flexible staff that can come over and help or assist in taking some phone calls. Maybe it's to have managers. Whatever it is, it's important that the people know what to do if something happens. That's the whole concept behind a process management plan. Now, also in the control phase, eventually you're going to reach a point where you're ending the project. And it's just important to take notes of some key areas where things may go wrong. Poor documentation. Make sure that the people, if the people who write the new process is not familiar enough or too familiar with the old process, the documentation may just not be up to par, right? We want to make sure that someone new can come in and read the documentation, understand it, and take it over. A bad handoff is also something to watch out for. So that's making sure that the new owners, the people that are going to be owning this project, now that you are done with it, understand what it is, why we did it. And by the way, make sure that these folks, the people you'll be handing your project off to, were involved with the project. They didn't have to be involved from the start, but at some point, especially when you get to the implementation phase, they needed to be involved. And don't let your documentation disappear. So, a lot of times those new SOPs that we spent so much time writing or designing wind up in someone's drawer, never to be seen again. We want these to be out. We want these to be visible to folks. We want people to take pride in those. Again, that's another important reason to get the people that are going to be managing the project involved with actually writing your documentation. And finally, when you're ending the project, it's time to celebrate. Complete your A3, prepare your final review, lessons learned, opportunities that you maybe didn't address in the problem. This is good for a couple of reasons, because you may have identified things that are important to the success of the overall process, but it was out of scope in your original project, or maybe you just didn't have the actual time to dive in and fix it. So it's also important to include opportunities that were not addressed in the particular project. It's also good for you and the team members that worked on a project to find some kind of way to stay involved. I mean, that may be getting a quarterly email, or they're on the dashboard email that goes out once a week, just to see. If you spend a lot of time on something, you invest a lot of yourself in something, you should never fully let it go. It's good. It's also good for the people that are in that process, working on it every day, to be able to reach out to you and ask you, hey, are we doing this thing the way that it's designed to? Or, hey, guess what? Remember how we did this? We've improved it even more. It makes people feel good. If you can find a way for yourself and other folks to stay involved with the project after you hand it off, after you've let it go, it's good for everyone involved. And finally, the most important thing when you're ending a project is to celebrate. Don't underestimate the power of the party. Get people together. Say, hey, we just spent a lot of time. We just gave a lot of ourselves to improving this project. It's time to celebrate. You can do this in a lot of ways. You can just have a little pizza party in the office. You guys can go bowling. Maybe go to a baseball game. Hopefully watch the Dodgers win the World Series. There's a lot of things that you can do to celebrate your victories. And whatever that celebration is, just make sure that we do it in some kind of way. Make sure you thank everyone on your team for a job well done. Some other things that just highlight, we want to make sure that we have updated our standard operating procedures. Good things to keep in mind is mistake proofing. or poke-yoke to ensure that we can't actually revert back to the way things used to be, and implementing possibly some forms of audits may be appropriate depending on the type of process that you are working on. Let's just do a quick knowledge check on the DMAIC process. In what DMAIC phase would a root cause analysis be carried out? Define, measure, analyze, improve. I almost said control there. And the answer there was C. The analysis phase is meant to understand the root causes of particular problems. What does a Pareto chart display? An analysis of value stream flow, the distribution of product quality, the percentages of the various types of waste in a process, the causes of problems or conditions from large to small contribution? And the answer there is D. The Pareto chart does show this running total in the form of a percentage sign, generally on the far right axis. Which tool should you use in the analysis and the analyze phase of DMAIC? A SIPOC diagram, Ishikawa diagram, value stream map, the CTQ tree. And I'm guessing you got it right, and that is the root cause analysis or Ishikawa fishbone diagram. Which tool would you use in the measure phase of DMAIC? SIPOC diagram, standard operating procedures, Ishikawa diagram, or value stream map? And value stream maps are very critical tools, especially when you're kicking off the DMAIC process, when you've created your process map, and you have to know your measurements along the way. A great way of putting that into play is a value stream map, which shows all the measurements for your entire process from A to B, to C to D. This completes Section 2A, Part 2. We have just completed our review of the DMAIC process, define, measure, analyze, and in this section we covered improve and control. If you missed the first section, please go back and review Part 1. Probably make a little bit more sense to you then. Again, I'm Anthony, and thank you so much for attending.